So this is Unit 2, Module 1, Lesson 2, Inequalities. You should have done the Fast Start activity and downloaded the startup file before you start. So this is probably, I guess, a little bit challenging for people to understand, just because the only experience that they've had with if statements is in geometry. And traditionally in a geometry class, you only deal with one side of the if statement, the true part. Everything you're taught in geometry is a true if statement. You don't really talk about false if statements. You almost automatically assume everything you do is true in geometry. Sometimes, yes, you do counterexamples, and sometimes you talk about the contrapositive and all that stuff, but really it's still essentially dealing with a true statement. In computer science, that's not the case. In computer science, we deal with true and false statements, and it allows us to direct the computer in its actions. It allows us to make decisions. This is not artificial intelligence by any means whatsoever. It's just a computer making a decision based upon some type of condition. It can't read into that condition. It can't do anything but that condition. The reason that's important to understand is because you need to write the conditionals in such a way that you accomplish what you're interested in. So we have to talk a lot about testing your conditional, making sure your conditional does what you expect it to do and does it in such a way that is efficient and makes sense. So here are the different types of conditions we can check. We can check if two things are equal. Notice the symbol we're using for equal. It's equal, equal. There is another way to check for equality when we're dealing with objects. We'll look at that at a later date. This is less than. This is less than equal to. This is greater than equal to, and this little exclamation mark here means not. So not equal to. The not also can apply to an entire condition. Not x less than y. Now what would that be? Think about that for a second. Conditionals have very limited opposites. The opposite, or the not, of x is less than y would be x is greater than or equal to y. Right? Take a number example if you don't believe me. 5 is less than 7. Sure. 8 is less than 5. Nope. It's greater than 5. 5 is less than 5. Nope. It's equal to 5. In mathematics, we call that trichotomy principle, where two values can only be compared as greater than, less than, or equal to. That's the only thing you can do with those values. So if it's not one, it's got to be the other two. If I said not x equal to y, equal in this case, what would the opposite of that be? If we said x equal to equal y and put a not in front of it, the opposite of that would be x is less than y or x is greater than y. One or the other is true. So here is how we do a conditional. If grade is less than or equal to 59, if that condition is true, then we will print out the result, in this case, failing. So if the user types in 92 and you enter your grade it'll say, of 59, it'll say failing. And I believe we talked about this in the last lesson, right? So just for sake of argument, why don't you guys try to do this? It's in the U-Try assignment in Blackboard. Input a temperature. It should be a double. Test if it's greater than 98.6. If it is, print a message that says you have a fever. Do that now. Pause the video. Okay. So if you haven't answered this, pause the video, answer the question. If not, I'm going to go forward to show you and talk about what the actual answer is. So you should have had something like this. If temperature is greater than 98.6, notice though the temperature has to be a double. We should comparing like types. That's important. Now, could you compare an int to a double? Yes, but you can't compare a string to a double. That doesn't make any sense. Or at least, you're not going to get the results that you expected. There are ways of comparing these things. Java will just do it. Java will just do the comparison, but it won't be comparing what you think. It'll be comparing something like memory address and value, not the contents of the variable. So you have to be very careful and make sure you're writing your conditionals, and Java does not help on a lot of these things. It'll just kind of push its way through it. A lot of other times you would get an error or something to help you out. Nope. In the conditionals, Java pushes its way through. We talked about this before. If you accidentally use the equal symbol rather than the equals symbol, Java could very well just say, yeah, that's true. X equals 5. I accept that as an assignment. That's true. When it's not. You mean for it to be a comparison of X and 5. Two bad side effects of that. One, it evaluates as true all the time. Secondly, you just changed the value of X. You just made it equal to 5. And that really is true. Right? If you were trying to compare it, you accidentally did the assignment by mistake. So if you type in something like 99, it does say you have a fever for the flavor of a Pringle. Boundary cases. This is where you get to the nitty-gritty of testing out your conditionals, making sure they do exactly what you expect them to do. So if we look at our previous example, the boundary cases for temperature greater than 98.6 would have been 98.59, 98.6, and 98.61. Making sure that we're to the left and the right and at the boundary case. Making sure we're testing it that it's going to do exactly what we expect it to do. Now, you don't have to test every number. That would be ridiculous. But you do have to throw in more than one value. One of the things I noticed on some of the programs you guys have turned in, it's clear either you're testing it and you're getting the wrong answers out and you're just going to submit it anyway, which I kind of doubt, or you're only testing a very small subset of values. You really need to test your program. Programmers go through and run beta tests on their software all the time. In fact, they will even do pre-releases to the public and call it the beta release. And anybody who's ever been a beta tester, when you've gotten that beta release, you know that there's going to be mistakes in it. It's going to do things that are weird. You should not rely on that software as 100%. They're telling you by saying it's a beta that there's problems with it. We want you to search for the problems. Now, it could be perfect. There may not be any bugs. But they need testers. Essentially, you're free labor. Anytime you download a beta version and you're using that software, you're free labor. You're making money on you. So, there is a practice assignment here. And you can do it in the template problem. You're to input two numbers and print the largest. You're to test if a number input from a keyboard is positive or negative. You're to test if an input from a keyboard is a valid test score between 0 and 100. You're to test if an input from the keyboard is even or odd. You're only allowed to do this in one if statement. For each, well, not all of them is one if statement. Each one of them can only be one if statement. So I felt, when I first designed this a couple years ago, people had a lot of difficulty with it, so I felt necessary a hint. So let's go through and take a look at some of the hints that I have provided for this. That way you know what direction to go in. So here's hint number 1. Store the first number in a temporary variable. Test if temp is less than the second number. If yes, change temp to the second number. Then outside the statement, print temp. So now it's actually going to make a decision with one if statement, but I'm using a temporary variable to store the value. Never would you do anything like this in math class. This would be like, it doesn't even fit in the same space. But you have the ability to make use of temporary variables and essentially flipping a switch. So for example, I'm going to store temp equals, let's say the first number was 15. If 15 is less than 76, then I'm going to change temp to the second number. So now temp becomes 76. If 15, let's say the second number was 7. If 15 is less than 7, it's not. So temp stays 15. Then outside the conditional, I print temp. So you really have to ask yourself the question, what am I trying to accomplish? I'm not necessarily trying to print the largest with the conditional. I'm trying to find the largest with the conditional and then print the result. See, there's an and there. I want to print the result. Print the largest. That doesn't mean you're limited to just having to put that print statement in the if statement. Most cases, you don't put the print statement in the if statement. In most cases, there's some other type of variable that is involved. So there's your hint for that one. Let's take a look at the second one. Test if a number input from the keyboard is positive or negative. Again, you need two responses. One that says it's positive, one that says it's negative. So I'm assuming some of you are running away right away up to the first solution, right, and doing that again. But is there another way? So here's my second hint. Store result equal to positive. Test your value against the absolute value. If it's true, where the absolute value and your result are not the same number, then say result equals negative in the if statement, then print result. If the if statement carried out, it'll say negative. If the if statement didn't carry it out, it'll say positive. All right, number 3. So my solution was to use integer division to come up with the answer. I'm going to leave that out there for you guys to figure out. Again, it's a hint. It's not meant to tell you exactly how to do it. But think about how integer division might help you figure out if a value is between 0 and 100. Okay? So question number 3. Knew this one was coming. Test if a number input from a keyboard is even or odd. So this absolutely sounds like a job for mod math. Anything mod a number is either going to be, anything mod 2 is either going to be 0 or 1. So think about your condition, how you would set that up. Again, you got to print odd and even. You might make use of another variable to store the word odd, and if your mod is equal to 0, then you change it to even. That's all. That idea of using a variable to present two different answers based upon a conditional is a very useful technique. It will simplify your conditionals. You don't need to use an and an or and an else. You don't need all of that. You're really just flipping a value. And the last one, if I can get to it. Oh, that was the last one. I thought there were 5. Okay, so that should give you significant numbers of hints to actually do this practice, and I think it's something that it's doable now. I think you can all write the code for this. You could write this all in one practice assignment. It doesn't have to be 4 different submissions. It can all be in one practice assignment. So I'll let you guys work on that. There is an exit ticket. So I'm going to ask that you would go into Blackboard and work on the exit ticket now. And then this practice assignment really is meant to be homework. So do the exit ticket now.